How we doing today? We're going to go through and talk a little bit about domain and range still in the second video of this particular section, but we're going to talk more about piecewise functions today. So let's get ourselves started here. We'll start with just a piecewise function. Again, a piecewise function, what it means is that we have different domain settings for different functions. So in other words, if x is less than or equal to a -1, then that means what those values are for x will be substituted into this function, x squared minus 2x. When the values are between -1 and 1, where 1 is included, then the value of the function will just be whatever x is. And then if anything for the x value is greater than 1, strictly greater than 1, then the value of the function will always be -1. In this case, what we want to do in this particular example is we're going to take some values, we're going to substitute them into this function. So if I take a look at the first one, when I substitute a -4 in for the x value. So if I look up here, I've got x is less than or equal to -1. So then that means what we have to use is we have to use the top one. All right, so let's get our pen on here. And let's see, okay, so -4. Here's an error that most people have a tendency to do. If I write it like this, if you write it like this, then it means you have to square the 4 first and then take the negative. So be careful, put this in parentheses, all right, and then -2 times -4. All right, so -4 times itself is a +16, and then -2 times -4 becomes a +8, and we get 24. So the value of the function f of -4 is equal to 24. Now I'm going to go through and I'm going to use a fraction here. I've got to put the -3/2, substitute that in here. So -3/2, that would push it to be, let's see, right here again. Okay, so we're in the same one. All right, so substitute -3/2. Again, my parentheses. So -3/2 squared minus 2 times -3/2. -3/2 squared, well, that's going to be 9/4. And then when we multiply here, I'm going to get a positive value. Basically, the 2's will simplify, they'll cross each other out because I've got a 2 in the numerator, 2 in the denominator. So then I'm left with plus 3. Well, I can't add those as they are, so I have to go through and get common denominators. So if this is 3/1, again, just refreshing our memory on these, I need a 4 here. So I have to take the 1 times 4, which means I take the 3 times 4. And I get 12. 21/4 is the value of the function. All right, so now if we take a look at the next one, if I am at -1, so this right here says that it is x less than or equal to. So if it's less than or equal to, then that means that I have to use it when it's equal to. So we'll go through and we'll use this again. I'm going to say -1 squared minus 2 times -1. -1 times itself is 1. -2 times -1 is plus 2. So 3 is our answer here. All right, let's get to something that's not from the first one. So if I have f sub 0, so then that means I am now looking at, this one. Okay, so f of 0, so that means we substitute 0 into this function when it's x. Well, that's actually a really nice one. It's 0. Scroll down, 25. So which one am I going to have to deal with? So if x is less than or equal to -1, no. In between -1 and 1, no. Greater than 1, that's where my 25 is going to be. So if I'm greater than 1, that means no matter what, it's always going to be -1. So for our last one here, no matter what, since it's greater than 1, it's going to be -1. All right, so all I did, again, was substitute the values in that we had in the parentheses, take a look at the domain, and then substitute the values into the function as needed and as directed. All right, so let's graph one. So This might be a little difficult on this device, but it is something that we will try here. So the first one says at 3, sorry, try that again. At x being less than 2, it's always going to be 3. All right, so less than 2. So anything this side, anything over here, it's going to be at 3. So let's see, 1 would be halfway up, 2, 3 would be here. And anything less than would be here. So it's strictly less than, so then that means that we're going to have an open circle. Circles aren't that easy on this device, but you get the idea. Try to get a line here. So if I go through now and do the line, right, sorry, I had to change the color of the thing there. So I'm going to start here. Oops, I'm going to start in theory. Try again. All right, I'm going to, well, we'll start over here. Okay, so that attaches there, and I'm going to have an arrow at the end because it's going to continue this way. So there's my first part. So I've just gone through and done this. I'm going to use 2 different colors so you can kind of see which is coming from what part. So we'll use green in this second case. If I am at x being greater than or equal to 2, so if I'm at, let's say, f of 2, 2 minus 1, that means I'm going to be at 1. And it's equal to. So at f of 2, I'm going to be up here at 1. So I've got a closed circle. Now this is a function, which means that it has to pass the vertical line test. So it passes the vertical line test here. When it gets to exactly 2, it's still a function because there's a hole here, but this is filling it in. So in other words, if I had a point here and a point here, this would not be a function. All right, so now let's go ahead and draw the line. So if well, actually, let's do another point. So if I'm at f of, let's say, 4, f of 4 would be 4 minus 1, which is going to give me 3. So if I'm out here at 4, then I'm up here at 3. So I've got 2 points. Now we can go ahead and play connect the dots. Let's see if I can get this to give me the right color this time. Should. So I start here. Nope, doesn't give me the right color. Oh well, not a big deal. You get the idea. And then from here, we'll go ahead and we will put the arrow on because this continues forever. Okay. So here's another example of a piecewise function. What makes this piecewise is that we've got 2 parts, hence the name piece. All right, so you've got a couple pieces here that you have to go through and graph separately. The next example we have, here's the graph of a piecewise function. Determine the formula for that function. All right, so we can use it as f of x or whatever we'd like. I'm going to go through and say, all right, we've got an f of x here. I've got 3 sections. I've got this section that starts with a closed circle, and then it moves its way to the left, so it's everything less than or equal to a -1. I've got this middle section, and then I've got this section to the right. So I'm going to give myself enough room. Oops, that looks really bad. That's all right. That's what erasers are for. And then now we're going to take a look at the domain of each, and we're going to take a look at what this equation is for here. So if I look at this one, it's a horizontal line. So I've got a constant function. Constant function, we remember, is some f of x is equal to a constant. In this case, the constant is at 1. So then no matter what the x value is over here, it's going to be 1. So I'll substitute the 1 right here. And then we'll say, all right, so for every value less than or equal to, so where's it at? It's right here at -1. So for every value of x that is less than or equal to -1, that's where we're at. Taking a look here, this is definitely a linear function, okay? And we know that we're in between -1, but we don't include -1. And we can't include -1 because it's already being used. And then we're going to go all the way up to 2, but it's going to include 2. So let's determine this equation here. If I look at the slope of this line, it's a negative slope. It goes rise over run, up 1, to the negative direction 1. So therefore the slope is negative 1. So negative x, and we got to figure out its y-intercept. So the y-intercept is right here, and that y-intercept is at 1. So negative x plus 1. And this happens between negative 1, not including it, and then it will be including 2. Take a look at this last part. Notice how here we have an open circle, and it's going to be everything greater. It's also another horizontal line, so it's going to be a constant function. So here I'm at negative 2, and then we know that x is going to be greater than, and strictly greater than, because it's an open circle, greater than 2. Okay? Now let's take a look at another example here. So a hotel chain charges, again, this is that whole think, show, and tell. I've got to think about what's important here. So $75 each night for the first 2, and $50 each night for any additional. Okay, so now we want to create, we know that the total cost is a function of the number of nights. All right, so let's pull out some information here. Total cost is a function of the number of nights.
You can take first block attendance.
So now, sorry for the interruption. So now we go through and we get our function set up here. So if I'm going to let n be the number of days, and we start out that I can either be there 1 day or 2 days. So, and it costs $75 each time. So if I'm there, it's $75 times the number of nights I stay. So if I stay 1 day, it's $75. If I stay 2 days, it's also $75 each day. So one of the questions here is determine T of 2. Well, T of 2, and the reason I'm pausing here is because I'm looking ahead to see what they're asking me, because I need to know what they're asking so I can go ahead and answer it. So if I stay there 2 days, then that means it costs me $75 for the first day, $75 for the second day. It cost me $150 to stay. Whoops. The pen has a little button on it. So to stay for both days. Okay, so that's $150. So now I've got to figure out, okay, so after that, it costs $50 a day. For every day past, well, the first 2 days are following this. So if I stay 3 days, it means I'm only going to get charged 1 day at $50. So then that means I'm going to do n minus 2, because the first 2 days are paid for. How much do first 2 days cost? $150. So then let's make sure that this makes sense. $150 was the first 2 days, $50 for every day past that original 2. So then that means for 3 and above, it's going to be this. All right, now we're not going to deal with any half days or anything else along those lines, but we are still going to make sure that we have a function. So if I say then, all right, fine, what has to happen for this particular example is that it's got to be strictly greater than 2. All right, so n must be strictly greater than 2. It's a discrete function as opposed to a continuous function, but we're going to leave it in this sense. So now let's think about T of 3. So if I put a 3 in here, that's going to be 3 minus 2. And then the 3 minus 2 is going to be 1. So I have $50 because I stayed the additional night, plus the $150 that I spent for the first 2 nights. So if I stay 3 days, it's going to cost me $200. If I go with 5, so then I'm going to have 50, 5 minus 2, so there's 3 days that I'm paying at $50 a day for a rate, and then $150 because I stayed the first 2. So 150 plus the 150 from the first 2, and that's going to give me a grandiose total of $300. Right here now it asks, what does T sub 5 mean in the context of this scenario? Well, it means that I paid the first 2 days at $75 each. Then I have 3 days that I'm paying at $50 each. Therefore, my total stay is going to cost me $300. that's what it means in the context of this scenario. Again, thank you again for your time. Hopefully this was helpful, useful, took some good notes, and when we get into class, we'll go through and we'll work on more of the practice problems. Thank you much. Have a great day.